Dear viewers, this video covers the overcurrent relay. So, as per that the syllabus, this is that the already we are seeing the universal torque equation, RX diagram, and electromagnetic relays operation. So now we are going to see the overcurrent relay types, different types of overcurrent relay, and the directional overcurrent relay, right? So now we are going to see the operation, that is the basic classification of a overcurrent relay. So this is the basic classification of the overcurrent relay. Okay, so OVR. First one is the that is the definite time overcurrent relay, or the instantaneous, that is the overcurrent relay. So that is instantaneous overcurrent relay. Just we are going to see now the what is that the difference of the instantaneous overcurrent relay. So this is the instantaneous overcurrent relay. Why the name is called the instantaneous overcurrent relay? So this is the current, this is the current, this is the time axis. Whenever the current reaches on its the specific value, the relay which can be operate, the relay can be operate immediately. The relay can be operate immediately the specified or pickup value, specified current. Suppose you are going to set that is the 25 amps is the pickup value. The magnitude of that the current, the magnitude of the current which may going to reaches that the what is this 25 amps, there is no delay, there is no delay. Okay, there is no delay is occur. So immediately the relay will be start working. So this is called the instantaneous overcurrent relay. So the relay operates definite time, that is the current exists, that is the pickup. So there is no delay, there is no the internal delay of that the system. It's very fast, and operating time is less than 1 seconds. The 0.1 second, the operating time is less than 0.1 second. So this relay which is called as the uh, instantaneous, that is the instantaneous relay. So on its characteristics is, this is the on its characteristics. The another types of relay we are going to see. So another type of that is relay, that is a definite time relay. So what is mean by the definite time relay? So if the current is, this is that the current, so this is the axis, the multiplex setting. So this is operating time. So if we are going to fix some the point, if we are going to fix some point, this is the point we are going to consider. After that some time, that is after that some time, again the relay will be start working, or it can be trip, or it can be the some internal delay operation, some uh, internal delay operations. So this is that the relay. Suppose assumed as so this is as the curve, this is the current, this is the operating, that is operating time. Okay, so suppose this is that the maximum current, and time it is available. So what we have going to taken as that the, this is the set point which is we are given, that is that the current which may be going to increases on that level, we are going to taken as this much of that the time, this much of that the time. So this is that some definite time we are going to taken to account for this system. But in the instantaneous relay, but if you are going to take an as the instantaneous relay, This is the time, this is the what is the pickup current, immediately this may be going to trip. But here but here we are going to take as some time, so we are going to take as the at some time. So this is that the point we are required. So what is our the time we have going to be given. So this is that the pickup value. So this is the pick up current, this is the pickup current. Assume this is the 25 amps. So at the time of that is the point um, not 1 second is occurring, it will take some x delay, and then operate the relay. Okay, so first point is that is greater than the setting value, then delay is occur, then trip. So that is then we are going to trip the system. First achieve the current, and then delay, and then tripping. So this is the point we have going to consider for the that is a definite time relay. But that is IDMT. So this is the different infinite definite minimum time relay. This is that IDMT. So mostly this relay which can be used for the distribution system. In our distribution system, which can contains IDMT. What this relay function, which means we are going to see that the basic operation of that the inverse. So this is our characteristics. So this is the operating time, then actuating quantity. Here the actuating quantity assumed as a current. This is actuating quantity. If the quantity level is high, the current is that is the current level is high, then the operating time is reduced. If the current level is low, the operating time is high. Suppose current, this is the 5 amps, this is a 10 amps, this is 25 amps. Suppose this point, so this point assume as a 100 amps or 50 amps. So what is this? This time is very much less. So the operating time, so the inverse time over current relay that operates when the currents exceeds on its pickup value. So any exceeds on its pickup value. So this is the PSM, plug setting multiplier. This is a time multiplier set. So this is that the process of this is called TMS or TSM. So time multiplier setting or time setting multiplier. So what is mean by that time multiplier set and time multiplier set? The different operating time times possible of the same relay. So same relay, that is the suppose that is the over current relay. So first of all, this is the curve. We are already seen that the curve, this is the curve. Which curve means if the current is increases, again the operating time will be reduces, right? If the current, this is I, this is time increases, but the same time if the that is the what it is says, the operating time it is possible for the same relay by adjusting the regular distance between the moving part of the relay and the travel closing to that. So we are going to assume that is the 25 amps relay, which may be operate in 0.5 seconds. Okay, and that is 1 seconds and 1.5 seconds. This option which can be used for time graded value, which is already discussed in the previous video, which is we are going to already discuss in the time grader. This is the time grader. Okay, so this time grader, how we are going to achieve same 25 amps, that is assume that is the current. One is 0.5 second, another 1 second, and 1.5 second. So the time graded value we are going to achieve by using this time multiplier setting, time multiplier, or some books will be referred as the time setting multiplier, TSM or TMS. So the same relay which can be adjust the traveling. So how, where it is seen, this is the physical part of the relay. Please see this part, please see this part. That is, I am also simply change, I think now it is visible. Yes, please see this part. Okay, so this is the part which can be see how that the system which can be TSM, that is the time setting multiplier, how we are going to be seen, right? So this is the time setting multiplier. So fixed mark, this is the mark is fixed here, mark is fixed here. So if we are going to change the physical position, I think the spring tension, this is nothing but the spring tension, adjusting the spring tension. This lever will also adjust again the NONC contact of the relay. NONC, this is the NONC contact of the relay changes. So this operation is achieved by the TMS, time multiplier set, or time setting multiplier. For example, TMS equal to 1, the operating time is 4 seconds. Same thing, TMS equal to 0.5, it is 4 into 0.5, which is 2 seconds. Then this is 0.2 means 0.8 second. So the same 25 amps, the over current relay tripping, which may be done in the 4 seconds or 2 seconds or 0.8 second. So that operation is known as the time setting multiplier, right? So now we are seeing the operation of that IDMT relay. Next we are going to see the very inverse operations. So this is the definite time. So definite time which may be going to already we are seen the definite time, the relay which can be operate some time. So this time is very inverse line characteristics, which means if the current magnitude of the current is further increases, please see this, very inverse time over current relay. If the magnitude of the very inverse, if the magnitude of the current is increases, the operating time is further reduces. Please see, suppose this is in the 4 amps in the IDMT. If the 4 amps, it will take the 4 seconds. Same time it may be going to reduce, that is that the 10 amps it may be going to operate, that is that less than, which means 1.85 seconds. So 4 amps it may operated in 4 seconds, and 10 amps it may be going to operated in the 1.8 second. So similarly, so that is the 13 point, that is the constant into TSM PSM minus 1, which means very inverse time overcurrent relay gives the more inverse characteristics than the plain inverse relay. Similarly, extremely inverse, the time current characteristics is more inverse than the inverse IDMT. So relay minimum time, that is the inverse definite time minimum time operating relay, which is we have going to be implemented by using these characteristics. So once again we are going to see here. So the definite time overcurrent relay means definite time. So the this definite time overcurrent relay, that is rated current which is greater than the 25 amps. We have some delay, after delay we are going to trip. Okay, So this relay is point, assume that is the 0.1 second for the operation. Suppose the current is in that, this is 0.01 for this IDMT, very inverse 0.001 or 0.05, that is 1 for some other that is extremely inverse. So this delay part is changes depends upon this magnitude of that current. So this definite time we have normally used distribution feeder, we are utilizing that the IDMT t is equal to 0 for that, for which position, that is instantaneous relay. Okay, next I is the pickup, very inverse and extremely inverse. So this is the overall characteristics of the what is this overcurrent relay. Okay, so the next before going to that, we are going to see that is the physical parts of time setting dial. This is the physical time setting dial. This is the PSM, the plug setting multiplier. So this is nothing but the PSM, plug setting multiplier. Okay, in next video we are going to see the basic construction and operation of that the relay of the relay, overcurrent relay and directional overcurrent relay. Okay.